Now, we can't just slap these on. We need to chamfer this corner, basically the inside hole needs a chamfer, because on the hub over there on the RV there is a big radius and this doesn't set flush. So how do we do that? Well, we have a lathe, but to hold these puppies I bought me a 4 independent jaw chuck with the backing plate that mounts on my lathe. It's D15, but this sucker is unfinished and not the best quality. Well, it's a rough finish, but this damn hole is pretty much identical to this damn hole. And that's our only register face to center this on this. So we need to improvise. I want this hole to be slightly bigger. There is a groove machined in here, so at least maybe to that groove. So basically we need to make a centering plug, and we'll drill a hole so we can still stick through the spindle. So I have a chunk of aluminum. It will do just fine because its only job is to make these two concentric. So the first order of business is to throw this in the chuck. Well, no, take the chuck. Take that chuck off. Mount this directly to the spindle. Face this. Bore this out bigger than this. And that would be the operation in that. And then we make a spacer with a hole. Then we marry these two. Then I can drill the 4 holes to mount this to this once they're concentric. That's the order of operations. So first, let's slap this on the lathe. There we go. We got a very fine finish. Now I do want to make this hole a tiny bit bigger. So let's measure up where we need to go. And that's how the back of the new chuck looks like. Right, all these holes. Anyway, it's 79.84, so basically 80 M&Ms. So we want to make that one 81, 82. Let's see what it is now. And this one right now measures 78.38. So let's take it up to like 82. So we touched off. We marked ourselves a 0. So since this is imperial and we want to go about 2 M&Ms, we need to take out 70 thousandths. So I went 40 thousandths, and we took a mil off. I'm like, something's off. Well, this is by diameter, so I need to take 140 thousandths, not 70 thousandths, because this is by diameter. Okay, makes sense. We're almost there. So 20 minus 14, we need to go back to 7. Yep. So yeah, for those who can do math, well, I wound this back up. 20 minus 14 is 6. So yeah, we're at 82 M&Ms. Okay. So let's chamfer the edge a little bit, and this puppy is ready. I figured out in bananas, because that's what my lathe is scaled at, the centering plug register to center these two holes over each other. So the total length of the piece, this diameter, that's the hole in each of these. Okay. Well, the good news is lathe is cutting just fine. The bad news is I was rushing and overshot this, so now this is too small. That's what she said. Anyway, so rather than removing this, we're gonna just flip it around and work from the other end, and don't rush this time and make it right. Here we go again, just from a different end. It's everywhere. Success. She fits. This thing is hot, so it will shrink a tiny bit, but it's a nice snug fit. So we'll just say it's good for what we're doing here. So now let's figure out the depth of the next one, and it is hot. Figure out what the depth is and whittle down to the next one. And don't mess that up. Well, good news, I did not miss, so we have a blank prepared. Now we need to punch a hole up to here, so basically a blind hole, so I can actually part it, cut it off. That's the biggest challenge on these things. So we need to make a hole first. Let's find the chuck, the biggest drill bit I have, and make a hole. And then we'll take a peek at boring it out. There we go. We successfully made a 1-inch hole. Now we can throw in a boring bar and make it this size. So more than an inch to go. We're working with a compound because that's like way too coarse, and we're making a hole bigger. We still have an inch to go. Oh, warm. So we hogged out the center hole, so now this little guy should reach that hole. So now we can part this off. I have locked the carriage, and we're gonna hand feed it in and see what happens. So since I need both hands, you're not gonna watch me struggle. Success! This little guy did great, and here it is. Now we're gonna throw it in the chuck. Ooh, everything's hot. Gonna throw it in the chuck and clean up the back face and adjust the length. Here we are. The two things are lined up via our spacer centering ring hub thingy-majig. However, chinesium shit again. These two things cannot go together. Although they're sold as a kit, some machining required. The problem being the mounting holes for the chuck to the backing plate is on the same circle, same diameter as the studs that mount the backing plate to the lathe. So the problem is you can never get 4 bolts tapped and drill, because if you get, basically I can only get 2, because the other 2 hit either the mounting bolt for the stud or the stud themselves. So that's the problem. They should be bolted on the side here, like some normal chucks do, and from the back end. Let's take it off and take a peek if there is a space to back drill and tap this guy. The diameter of this bolt hole matches the diameter of these bolt holes. So, and there is nothing here to drill and tap into because they didn't provide any material. So, what we're gonna do, we're gonna punch 2 holes only, because if 2 won't hold it, 4 never will. We have our holes marked, you see, it's on the same freaking circle. We have a centering bit, we have a 8.5 drill bit, and M10 by 1.5 tap. Let's move the production to the drill press. Here it is, the sandwich is together. Let's stick it on a lathe and see how untrue it spins, but that doesn't matter. It's independent jaw, so we center the workpiece, not the chuck. But it should be pretty good for who it's for. Well, let's see. I like it.